Now we're going to learn how to solve one-step equations using the tape diagram method as well as the balancing method. And so I wanted to show you guys both methods because those are two ways in which you can show your thinking and model your mathematics. So let's take a look. So I got x plus 3. So what I'm going to do is I'm going to draw this tape diagram. So x plus 3, and that entire thing must equal to 7, right? So this entire thing, if this entire thing is equal to 7 and this is 3, what must this be? This must be, well, 4, right? Why? Because 4 plus 3 is equal to 7. Therefore, x is equal to 4. Another way that you can solve that is 7 minus 3, which is equal to 4. And now x is equal to 4. 4 plus 3 is equal to 7. Another way is balancing your equation, or the balancing method, is that this is x and this is 3. And then you have 7. As you can see, this equation is balanced because both weights are the same. They weigh the same. Now, automatically, because we've already done this, that this has to be 4, right? Because 4 plus 3 is equal to 7. And if it's 5, this will be heavier than this because this entire thing would equal to 8. And now we want to keep it the same. Therefore, we need to make sure that this x has to equal to 4. Now, another way that we can solve this is by actually making this 7 into 4 and 3. We can do that, right? And the reason why is because 7 is the same thing as 4 and 3. Because 4 plus 3 is equal to what? 7. X plus 3 is equal to x plus 3 is equal to 7. So this right here means that this value is equal to that value. They weigh the same because the equation is balanced, or the weights are balanced. And so what can I do? So if I take away 3 on this side, I must also take away 3 on this side to keep the equation balanced. If I took away only this 3, then this is going to weigh more. I can't have that. And then the scale is going to tip like this. It's going to look like that. We don't want that, right? We want the balance. We want the scale to be parallel so that we know that the weights on the left and the right are equivalent. And so if I take away 3 from the left side, well, I also have to take away 3 on the right side. So then what's remaining? Well, what's remaining is we have x on the left side and 4 on the right side. Therefore, x is equal to 4. All right, well, let's try another one. Let's try x. Since we did addition here, let's do x minus 2, right? So then we got here, we got the tape diagram, we got x and then minus 6, and this entire thing is equal to 2. Now you might be wondering, okay, what number needs to be x in order for the value to be 2? And I think it's going to be a little bit tough. So some of you guys might already have figured it out, but let's go ahead and try the scale method, and maybe the scale method will give you a better answer. So we got x here, and then we have a -6 block, right? X block and a -6 block, and they all must equal to 2. So, well, let's take a look. What I'm going to do is I'm actually going to try to get rid of this -6, because our goal is to try to find what 1x is equal to, right? So I can actually do this. How can I do this? Well, I can, as long as I add something to the left side and to the right side, it's going to be okay. Because that means that the equation will continue to be balanced. So whatever I add from the left side, I also have to add to the right side to keep the balance balanced, right? But if I only add to the left side, what would happen? It would become like that, right? We don't want that. So if I do to one side, I also have to do to the other side to make it balanced. So what I'm going to do this time around is I'm actually going to add 6. I'm going to add 6, right? But if I have to do to the one side, I also have to do to the other side. I'm going to add 6. Why did I add 6? Because negative 6 plus 6 is what? That's 0, right? So that actually cancels out. And so what's remaining? X is equal to 2 plus 6, which is equal to 8. So my answer is x is equal to 8. Well, now let's take a look here now, right? Let's just say I put 8 here, right? What's 8 minus 6? 8 minus 6 is in fact 2, right? So it checks out. So the diagram really helps to figure out what this number could be, okay? All right, let's try another problem, okay? So I got x plus 4 negative 2, okay? I'm gonna use both the tape diagram. So this is gonna be, I'm gonna get x and 4, and this entire thing is equal to negative 2. Once again, it's a little bit difficult. What x value do I need to get in order for this to be negative 2, right? What number plus 4 is equal to negative 2? I mean, I could try 6, but 6 plus 4 doesn't equal to negative 2. So that doesn't work, right? And so it's a little bit difficult to use the tape diagram to guess and check. So why don't we go ahead and try the scale method. And so what I'm going to do is, this is the x and this is the 4, right? And this all is equal to negative 2. Remember, we want to find out what x is. We want to get x by itself. So how do we do that? What we're going to do is we're going to actually take away this 4. I'm gonna take away this 4. Okay, but if I do to one side, I also have to do to the other side. Keep the equation balanced, right? If I only add to the one side and not to the other side, this line or this balance will not be balanced, right? This scale will not be balanced. So in order for it to keep it balanced, we have to make sure that we are doing it to both sides. So 4 minus 4, then that becomes 0. Okay, that cancels out. So what's remaining? X is equal to, well, if there's negative 2 and negative 4, adding them together, we get negative 6, right? Well, let's take a look. X, right? We got negative 6, right, as this number. So negative 6 plus 4, does that equal to negative 2? If negative 6 plus 4 equal to negative 2, well, let's take a look. So we got negative 6, 1, 2, 3, 4, 5, 6, and then plus 4, 1, 2, 3, 4, 0 pair, 0 pair, 0 pair, 0 pair, and what's remaining is negative 2. 2 negative counters are remaining, therefore my answer is in fact negative 2. All right, let's just do one more problem, just for good measure. I'm going to do negative 6 plus x minus negative 4. So let's take a look at this one. I'm going to draw another tape diagram like this, and then we're going to have negative 6 and x, and both of them equal to negative 4. Now, some of you guys can figure this out. You guys can guess and check. I'm already thinking negative 6 plus 2 is equal to negative 4, right? That makes sense, right? Negative 6 plus 2 is equal to negative 4. Negative 6 plus 2 is in fact equal to negative 4. Why? Negative 6. That's 6 negative counters. I'm going to add 2. That's 0 pair, 0 pair. And what's remaining? Negative 4. So it does in fact equal to negative 4. But I want to check with my scale method. So what's on the left side? Negative 6. What's on the right side? Negative 4, right? Negative 4. So how do I get rid of this negative 6? The way that I get rid of this negative 6 is by adding a positive 6, right? Because they make 0 pairs. Negative 6 plus 6 is 0. And if you do it to one side, you also have to do to the other side. And so this cancels out, that cancels out. And what's negative 4 plus 6? Well, negative 4 plus 6, like we did here, is in fact equal to negative 4. So negative 4 plus 6 is equal to negative 2. Or positive 2. Positive 2. So negative 4 plus 6 is equal to a positive 2, which is in fact what we got right here. Negative 6 plus 2 is equal to negative 4, and negative 4 plus 6 is positive 2 right here. And what's remaining on the left side? X is remaining on the left side. Okay?